Hi, Blessing. This is Mr. Green. I'm making a recording for the class Connect for this week because I am giving a STAR test. I feel you're probably taking a STAR test too, and I understand that, but you can watch this recording when you get a chance and also do the lessons that you need to do for this week without a problem. Okay? Uh, we are finishing up Unit 3. We're going to be taking up a couple more theorems that deal with splitting triangles up, and then we're going to look at area and volume ratios, and then I'm going to do a quick review today. Okay? So you shouldn't have any problems with what I'm doing. Look at this. We've got two triangles that are sitting here like this. These triangles have what are called an altitude. See how it makes a 90-degree angle right here? This dotted line does. It's going from a vertex down to the base, making a 90-degree angle. That's called an altitude. And one of the theorems that we were given in the book tells us that this altitude will also be in ratio to a similar triangle's altitude. So since these two triangles are listed as being similar, you can say that x over 6, well, how did I get that? Well, I went from x to 6. I went from one triangle to the other triangle, will be equal to 24 over 8. Now we can do our means and extremes. 8x will be equal to 6 times 24. And I can't do 6 times 24 in my head, so 6 times 24 is equal to 144. So 8x is equal to 144. I'll divide by 8, and x will be equal to 144 divided by 8. Going back to my calculator real quickly here, I'm going to hit divide by 8, and it will tell me that that is 18. So x is equal to 18. So we just found that this altitude is 18. Woo-hoo. Nicely done. Okay? This is used a lot in aeronautics when planes are flying around, because they will know how far the plane is from the radio tower, because the signal strength will tell them that. Okay? And then they'll know how tall another thing is, like the radio tower itself, and they will be able to figure out how high the plane is. And it's all done electronically, so it happens very, very quickly. But that is the concept behind that process. Now, one of the other theorems that's there talks about using the median. Now, medians means that I'm dividing one side of the triangle in half with a line from a vertex to that middle point, median point. Okay? And then we can set up ratios of the sides and that median. Well, this median is 12, and this one over here is x. 12 over x will be equal to the sides that we've got, 14 over 6. You see how I started with the 12, went to this one, I start with the 14 and go to this one over here. Those will be equal to each other. And we can set up our means and extremes. 14x will be equal to 72, because I multiplied 6 times 12 and got 72. X will be equal to 72 divided by 14. So what is 72 divided by 14? 14 is equal to 5.1. So x is going to be equal to 5.14. Okay? That will be the value that you would have for x right there. Okay, let's look at this one. Here we've got a flagpole, and we've got a sign sitting here that's only 4 foot 8 inches high. And we know the distance from the flagpole here, the flagpole to the sign is 19 feet, and from the sign to this point right here is 6 feet. Well, this is the shadow of the flag. Okay? And it goes right through the top of the sign, and it hits right there. And so we can use that shadow to set up some ratios. Now the problem is, this is a triangle situation. Okay? And so we need to make certain we're using the sides of a triangle. So 6 and 4.8 are the sides of a triangle. 6 is the side of that small triangle, but 19 feet is not the side of this triangle. we've got to add the 6 onto it to get 25 feet down here as the whole side of the triangle. And you've got to use that whole side of the triangle to make this work correctly. Okay? So we're going to say that x over 4.8 is going to be equal to 25 over 6. Now we can do our means and extremes, and 4.8 times 25 is 120, and that'll be equal to 6x. If we divide by 6, x will be equal to 20. That means the flagpole is 20 foot tall in this situation. Do you see how I had to use the entire length here? Make certain that you're using that entire length when you're doing these type of problems, because that makes a huge difference. Now, the other topic you're taking up this week is one that deals with uh, area and volume ratios. Now, we know that we can, when we're dilating something, when we go from big to small, we can just write down the sides, 14 over 7. That's called the scale factor, right? The scale factor. Well, 14 over 7, which is equal to 2 over 1. I simplified it a little bit there, but that's the scale factor. Now, when we want to look at the area, like the base areas or the surface area, area is made up of units squared. So what we do, that's equal to the scale factor squared. So in this situation, it would be 2 over 1 squared, which is equal to 4 over 1. And if we want to look at the volume, we know volume is made up of units cubed. So we would take the scale factor and we would cube it, or to the third power. And that's equal to 2 over 1 to the third power, which is equal to 8 over 1. So in this particular problem, they're giving us the volume. They're saying that this one is 1120, and they want to know what this one is over here. Well, that's volume, so I'm going to use 8 over 1 is equal to 1120 over x. Well, that's 1120 equals 8x. That's x is equal to 1120 divided by 8. I can't do that one in my head. 1120 divided by 8 is equal to 140. X equals 140. So the volume over here is 140 inches cubed. Okay? Now the true trick is making certain you know this right here. How to take the scale factor and turn it into the area factor and turn it into the volume factor. You have to be able to get all three of them there, okay? Here we've got a similar type thing. We've got two similar cones, and one of them is 12 and the other one is 15. Well, that reduces, doesn't it? If I take a 3 out of both of them, I get a 4 over 5. Okay, well, if I wanted to find the area ratio, area, that's going to be equal to 4 over 5 squared, which is 16 over 125. And if I wanted to find the volume, it's going to be 4 over 5 to the third power. Okay? And 4 times 4 times 4 is equal to 64. And 5 times 5 times 5 is 125. Now they gave me this one over here, and they said this one was 256 pi, and that's cubic centimeters. That's centimeters cubed. So that means we're using volume here, right? Because they told us the volume of one. And we want to find the volume of the other one. So I'm going to write down my volume ratio, 64 over 125. And that's going to be equal to, this is the smaller one, so it's going to be 256 pi divided by x. We don't know what x is. Means and extremes. 64x is equal to 125 times 256 pi. Okay? X will be equal to 125 times 256 divided by 64 times pi. I can do that on a calculator. So I'm going to say 125 5 times 256 divided by 64 is equal to 500 pi. And that's what the volume of the big one is going to be, 500 pi. Okay? I want you to notice, if I use the 4 over 5 and multiply it times 256, I don't get 500. So that's not, you can't just do that. Okay? You've got to do these squaring and cubing to make certain you know how to find the scale factor, the area factor, and the volume factor. That's how you do those type of problems. Okay? Now, a quick little review. Here we've got PA is equal to 8 and PR is equal to 24. And we're trying to find LE over here when LT is 6. I'm going to set up the ratios. 8 over 24 is equal to LE over 6. Means and extremes. 6 times 8 is 48 is equal to 24 times LE. LE will be equal to 48 over 24. Okay? So let's take a 12 out of both of them. That gives me a 4 out of 2 is equal to LE, or LE. That's not right. Let's see here. What did I do wrong here? 48 is 4. Yes, 4. And divided by 24. Yeah, that's 2. So I get a 2 there. So LE is going to be 2. Woohoo. Let's go on and do this one. Cell tower. We're going to do the same sort of thing we did with that flagpole. We got shadow that comes down like that, right? We've got a stick in the ground that's 4 foot high, or 4 meters high. They want us to write down the ratios for this one, okay? To find the height of the cell tower. I need to know the distance on this side of the triangle. 40 plus 5 is 45 meters, okay? So what are we going to have? We're going to have 4 over the x, the height of the cell tower, is going to be equal to 5 over 45. Means and extremes. 160 and 20 is 180. I'll have 180 is equal to 5x, and x is equal to 180 divided by 5, which is 36. So this would be 36 meters high. Okay? Here we've got another triangle that's got medians. See how these are divided in half? Medians. And they're telling me AF is 16 and FE is 4. AG is 12. So if we're trying to find this value right here, x, I can set up my ratios. 16 over 4 will be equal to 12 over x. That's 16x is equal to 48. That's x is equal to 3. This distance right here would be 3. Okay? Here, it's hard to read real closely, but this is a 28 up here. Okay? And if we were wanting to write a scale factor of large to small, I would say 28 over 12, which reduces into 7 over 3. And they're wanting to know the ratio of the area. Remember, ratio of the area is going to be the scale factor squared. So I'm going to take 7 over 3 squared, which is going to be 49 over 9. That's how you find the scale factor. Okay? Here we've got a triangle, and they're just wanting me to identify the dilation point, okay? Some information about the dilation. So they're telling me that this is the triangle that is the pre-image. Pre-image means the one you start with, okay? And then the image is the one that you wind up with. So they're wanting to know, identify the pre-image points, A, B, and E. Identify the image points, A, C, and D. And then what type of a dilation is this? Well, obviously, it gets bigger, so it is an expansion. Okay, it got bigger. If it gets bigger, it's an expansion. That means that my scale factor was greater than 1. Right? Because if the scale factor is greater than 1, it gets bigger. Okay. Here we've got a point going from here to here and from here to here. That's what this question is saying right here. Okay? And they're asking, is the scale factor greater than 0? Well, my scale factor goes from 2, 2 to 4, 4. So it's like it's 2, isn't it? My scale factor is equal to 2, and that's definitely greater than 0. Okay? And this point goes from 1 to 2 and from -3 to -6, so yeah, it is a 2. Now, if it was less than 0, it would have been back over here somewhere, wouldn't it? Because that's a negative number that's less than 0, and that means it has to scale through the origin, okay? And you would get points like this, okay? This one over here just means that it got bigger, so it has to be greater than 1. Okay. The volumes of two similar solids are 20 and 540. 20 divided by 540. You know what that reduces down to? 1 over 27. Oh, they said from the larger figure to the smaller figure. I'm sorry. Turn it around the other way. Okay? Put the larger one on top and the smaller one on bottom. Sorry. So that'd be 27 over 1. And they're asking, what's the ratio of the sides? Well, remember, we go from the scale factor, which is the ratio of the sides, and we cube it. We multiply it times itself 3 times to get the volume ratio. So what I'm going to do is I'm going to say, what number multiplied 3 times gives me 27? Well, that's 3 times 3 times 3. So my scale factor in this situation is going to be 3 over 1. Okay? Now, how did I find that scale factor? Well, I used the calculator to do it. Okay? And I said, I need to know what the cube root of 27 is. And so I actually pressed math here. And you see number 4 says the cube root. And since it was 27 that I was dealing with, I put 27 in there. And it tells me that the cube root of 27 is 3. So that's how I got 3 as the scale factor. Okay? Going forward. On a coordinate plane, the origin is the center of a contraction with a scale factor of p. Well, the way you would find that p, given that the pre-image points are x and y, you would multiply p times x and p times y, and your new point would be at pxy. That's how you would get that point if you were looking for it. Okay? Because you're going from the pre-image point to the image point, and you multiply the pre-image points times that scale factor. Okay? Similar triangles are defined as having at 2 angles that are equal. Okay? But it could be defined as having triangles that have 2 sides that are equal with an angle in between, or all 3 sides as equal in proportion, right? That's what you're looking for when you're looking at scale factor, when you're looking at similar triangles. One more. We got it, or a couple more here. We've got a building. It casts a shadow down to here. Okay? And they're wanting to know how tall that flagpole is. Right there. Well, we got to set up our ratios. 76 is the height of the building. We don't know the height of the flagpole, do we? We need to say that's equal to the distance from the building to the end of the shadow. So I need to add those two together, and I'm going to get 57. 57 divided by 9, because 9 is the distance from the flagpole to the end of the shadow. Now, means and extremes. 9 times 76 is equal to 57x. Divide by 57, x is going to be equal to 9 times 76 divided by 57. 9 times 76 divided by 57, and I get a total of 12. So x is equal to 12. So this would be 12 meters high. Okay? One more try with these, with going from side measurements to the ratio of the sides. So I'm going to take 45 over 36. 9 goes into both of those. It's 5 over 4. So my ratio of my sides is 5 to 4. The ratio of the area of the bases, that's area. So I'm going to take 5 over 4 squared, and that's going to be equal to 25 over 16. And the volume is going to take 5 over 4 to the third power, and that's going to be equal to 125 over 64. Okay, you see what I'm doing here? Volume cubed, area squared, sides, nothing, just 1. Okay? If I'm trying to prove triangles similar, I've got to set up the ratios. This is actually a 5.4. So 5.4 divided by 1.8, the similar side over here. Is that equal to 4.5 divided by 1.5? Is that equal to 6 divided by 2? Yes, all these equal to 3 over 1. Okay? So I could put an S right here and an S here because those are proportional sides. S here for sides and an S here for sides. So I could say side, 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 similarity. But I also want you to notice this angle equals this angle over here. And so I could say side, angle, side, similarity. If this question was presented to you as a multiple choice question, only one of these would be presented as a good answer. And so you'd have to be able to pick out, it could be one of those. You might look at it and say, oh, there's no right answer. But you have to go back and look at your diagram, see if there was another way of doing it. Okay? Okay. What we are doing here, these are the teaks that go along with the review. Okay? This is the end of Unit 3. Okay? Secret word for today is fun. So after you've watched this recording, please send me a K-mail telling me that you're in Geometry Blessing and the fact that the secret word for today is fun, and I'll give you credit for having watched the recording. Okay? And I look forward to seeing you next time.